Well, hi, good morning. Thanks so much for joining me here in my shop on October 14th. So today the plan for this radio is to replace the filter capacitor, check a few resistors, and then complete an alignment, and that's it for the radio, pretty sure. And I expect things to go well. We're going to start off by looking at the schematic and just studying up on the power supply a little bit. So here's the schematic here, and let me just make sure, model 47, make sure I've got the right one here. So here's the power supply. It's very, very typical of a power supply. The only thing about it is they're using a technique to develop a negative voltage with respect to the chassis. And that's by attaching the chassis, or I guess the chassis, or well, it is the chassis. I'll just keep calling it that. Attaching the chassis to a point that isn't fully negative. The fully negative spot in this radio is right here. So by doing this, everything attached now to the chassis is a little bit positive to this area. And I think I mentioned yesterday, this part of the circuit is only connected to the grid on the output tube. So that's how the grid ends up a little bit negative. Just a bit of a trick. So you could almost think of this as a cathode resistor. You could almost think of it that way. Its value is very similar to cathode resistors. 270 ohms. I'd be suspicious of this resistor, and the reason is it's a high wattage resistor. We got the parts list handy. What was the number again? 23. 1 watt. It's a 1 watt resistor. So the reason it's a 1 watt resistor is the designer expected it to carry a heavy current and get warm. So if it gets warm, it gets old. Gets worn out. So probably, I'm going to guess, this is probably 350 ohms now. But we'll check it and find out if my guess is correct. And then we have, in this filter system, we have this fantastic field coil in the speaker, which is, from my experience, doing the bulk of the filtering to remove the power supply hum. These two capacitors are notably small compared to lots of radios. You would find a 50 microfarad capacitor here, or even more. Here they're quite small, 10 microfarads. Again, that's suggesting you don't need much here to augment the effect of this coil. Okay, it gives you the resistance of the coil. If we get suspicious, we could measure this and try to determine if there's some trouble in the field coil, but I have no reason to do that at this point. So let's take a look at this capacitor. I think it's been replaced once. Not exactly sure if it has. Maybe we can figure that out. It's a likely target of an early replacement, and work has been done in this radio. Excuse me, so wouldn't be surprised if what's in there is not the original. Let's go look at the radio. Can flip it up here? I think just to double my safety here, I'm going to unplug it. Here's the big guy that we want to replace, or consider replacing. Yeah, we're going to replace this, sure. Now, come to think of it, last time I looked at this, I determined that this metal band was riveted into the bottom of the radio. It's also a Philco capacitor, so that pretty much tells the story. See the negative line coming up here, a green line going down to here, and a red one coming up to here. That's the output tube. Very good. Now where's the resistor? There's the resistor there. So here's the green wire. The other side, it's not going here. Maybe it is. I'm trying to see the wire. Let's bring on the spotlight here. camera will kind of compensate for it. End up looking kind of the same, but it's a lot more light in here for my eyes to use. Definitely this resistor is connected here. Other lead is connected to this terminal. Pretty sure I can see a bare wire coming here, here, and then carrying on. Oh, maybe it's this capacitor here. So how does it get back to this green wire? It was right across the two positive leads of the capacitor here. Let's track back from this one. There's a red wire that's going over here. There's a yellow wire, it's very hard to see, down under. It looks like it's coming to this terminal, and there's a wire carrying on. Can't move these very much. It's either passing this terminal or connecting to this terminal. The resistors on this terminal tied to this terminal. I'll bet you all these are hooked together. We're probably, I was going to say we're probably looking at the B minus, but no, we're on the other side of the power supply. We're on the positive side. There's pretty much no doubt this makes it back to this connection somehow. Let's put a little ohm meter on it. Not really a lot of need to investigate this, but why not? How's my battery doing? Battery. There we go. This switch has become somewhat unreliable. My battery's low too, so I gotta keep an eye on that meter. So we want to follow from this terminal and just see if there isn't a zero. Not there. Trying to touch the actual lead right on the resistor here. I saw a yellow wire coming up. Does it touch there? Did my meter stop working? No. It's definitely a yellow wire. It would have to bypass and go past this terminal. How could it possibly do it? Because there really isn't a yellow wire. The yellow wire I was tracing actually goes down here. So I have a red wire, yellow wire, checkered wire, and the positive lead. Is there something I'm thinking wrong here? That's not the resistor? Sorry, I'm clearing my throat a lot. I got a little bit of COVID. No, I don't. Well, that's a little odd. Okay. I'm suffering from cognitive dissonance here. Red, 10, 250, 350. Black, negative. Yellow, 10, 250, 350. Green, negative. Negative is right. Sometimes these wire colors will change. Let me just rotate this around this way. But these don't look changed. The green looks green, and the black looks black, and the red looks red. Oh, there's another wire. Okay, I should have asked myself, where's the yellow wire? I should have asked myself, where's that yellow wire? Okay, so now, so we've got, well, why would they bother with two negative wires? That would appear I'm caught in paradigm thinking. I just can't picture this resistor sitting between the negatives. I'm picturing it sitting between the positives, because that's where these resistors are commonly found, where this field coil is. So I couldn't break away from my paradigm thinking. Right, so there's two negative leads coming out of this capacitor because you need a place to connect the resistor between them. So I've just been upside down and backwards on this. Okay, so we go back and then look for this resistor between the two negatives, the black and the green, and of course they got to be different colors because you need these to be done properly. You can't have this wire come over here. Yeah, and likewise. So that's why they're colored. That's why they're there. Okay. Let's go see now if my updated paradigm, expanded paradigm, works here. Yeah, it's very hard to get things out of your head. I have a hard time getting them in. Once they're in, I can't get them out. I think that's just normal humanness. Okay, so somehow this wire should be connecting to one side of this resistor. There's the resistor resistance, 279. The other side's got to be at 0. Okay, somehow in this radio that's done. And then the green one comes right over and connects right to the resistor. So, okay. Deal is done. Now that says something about how I go about doing these replacement capacitors, because the paradigm would have had me figuring out which one of these was, the negative. I would have gone for this one visually. I would have put both the new capacitor negatives here. And when I went to stick the positives, it's probably when I would have run into trouble. Maybe I would have seen the next wire down here. I mean, who knows what would have happened. Nobody ever knows what would have happened or what will happen. We don't know. Okay, good show. At least now I feel much better about what I'm doing. So I need to find some capacitors here, small capacitors, say 10 would be ideal, that can withstand 350 volts. Okay, need to rummage for those a little bit. Okay, two little capacitors with short leads. So there's a challenge here, and that is this big capacitor with its long wires can be kind of connected, spread apart all over the radio like it is. These guys can't spread out that wide. So I need to cleverly figure out how to connect them. Well, one of them's obvious here. One can go like this. The other one needs to go between green. Oh, which one of these is which? Yellow, rather. Yellow, Jim, yellow. Could interconnect the negatives by accident. Like, does this green go with this red? I gotta be a little more careful with this than usual. Usually this is really simple. You don't have to think much. Boy, that's a danger, isn't it? You don't have to think much normally, and you don't think much. Wow. Okay. I'm gonna stop and just think about this a little bit more. Okay, well, maybe they've put a hint here. You'd think they'd want to communicate, which positive goes with which negative. And it could well be the way they've done it is they go red and black, and then they go yellow and green. So I'm going to guess that the red and the black go together. That's often the case in electronics, especially older stuff. Red and black, green and yellow. I think the telephone systems works like that a little bit. Maybe not, though. Maybe not today. Well, one of these goes right onto the rectifier, and the other one is going somewhere else. One of these goes right on to the, that doesn't help. The resistor is connected right onto a terminal here, but I can see already the pin is missing in the tube, so this is just a connection terminal. It's not a tube terminal. I can't use it for geography here in the radio. This one comes up to this tube and ties to two terminals, and the pins are in the tube there. Why don't we try to identify this wire on the schematic to start off with? So the tube involved is the tube at the front of the radio, and the pin number is 1, 2, 3, 4, 5, 6, 7, and 8. 7 and 8. 7 and 8 tied together into a negative on this tube. Okay. Now what tube is that? So there's a direct connection. That's the output tube. That's not the tube we're after. Where's the tube layout diagram? It's the 6A8 tube. 6A8, and they did not number these at all. How can this resistor one side's connected right to ground, and that's on, and one side's connected right to the tube, to the actually to the filament. So we should be, and it's either side of the field coil. We should be able to recognize this pretty easy because of the tube connection right here. I think I already saw that. So if we know this, then the other side of the same one should be connected to the non-grounded side of the 270. Okay, so I'll just say that again. The positive terminal that is connected to the 80 should match the negative wire that goes to the non-grounded side of the 270. I'm not going to remember this as soon as I look away, but let's give it a go. Right. What did I say there? First, non-grounded side of the 270, just to be sure. Let's find the grounded side. Maybe we should see the voltage. Here we are, 270. That's the non-grounded side. So that's the side we're interested in. So the green wire is the non-grounded side, and it's supposed to match to the wire that goes to the 80. So this and this go together, and therefore, yeah, God, I was thinking of hooking the capacitor across here. No, it's got to go from, the other one's got to go from here up to here. That's right, the other side's right on the chassis. Once it's right on the chassis, I have lots of places to connect it. I have other choices. Let's get one done. Get one done. So I can't stretch my little capacitor all the way, but I can cut this wire and use the wire. For any free terminals. There's a free terminal here, but there's a tube pin in there, so that doesn't sound too attractive. Non-grounded side. So I'm going to have to just put an extension wire on here to just feed the extension wire down to here. I'll go this way, negative, positive. Cut this wire and then just pull it up. We can try. I'll use the original wire if I can. But chances are, when I go to pull it up, it's going to not cooperate. Leave a little leg sticking out here. I've cut a wire. We're on our way. That's pretty flexible. Is that going to make it? I think it will. That'll leave this kind of floating a little bit, but it's a very light capacitor, and it's going to be soldered right here on a fairly short lead. So it should be pretty rigid. Okay, I'm going to put that one in. I think I'm going to double check what I just went through on my own, and then I'll install it. I want to be doubly sure I've got it right. No guarantees. Okay, got that done. It was a little more difficult than expected. I think I've missed all the mistakes. Sure. I just want to get rid of these wires now. I wonder if it's better just to leave the ground wire connected. I wonder. Let's get rid of this. And then we want to get rid of the yellow one, which I used. Okay. Green wire. Black wire. Okay, that little bit of surgery's done. Let's turn on the radio. Now, the kind of hum that was in it didn't strike me to be a power supply hum, but we will see. Set is off. Plug is in. Power on. Definitely through the dim bulbs this time. There we go. Well, it wasn't much of a... Well, quick, I have both bulbs in. So hardly any restriction there. But if I'd done something terribly wrong, we'd know from those bulbs. 108. Well, that's worse, if anything. Uh-oh. Uh-oh. What's with all that noise? Slowly going away. The hum is worse. Uh-oh. Didn't want that to happen. That hum sounds like a high impedance to the grid of the preamp tube off the volume control. Volume control sounds good. No scratchiness. Uh-oh. That's the hum that was there before. Wow, I went quiet there. Oh, it's another fine mess I've gotten myself into here. Well, this'll never do. What happened? So I did relocate some of the connections, of course, from where they were originally made to other alternate spots, which I thought were harmless choices. No, I think I boobed up. I think I did something there that I shouldn't have done. And I went and cut away the original one. Duh, I should have left it in there in parallel at first. But that might have even been worse. I don't know what to think. Ay, 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 ay. Son of my gun. Okay, just gonna stop, calm down, figure out what I've done here. Before I start thinking any harder, I'm just gonna cut this guy right out of here. Pretty sure I can cut through the band. I can cut through it here even. Okay, so I muttered something about hooking up the ground of this capacitor to this black wire, which is then going through a hole up top. It's going through a hole up top. Exactly where it's coming out. Let's go right into the transformer. Maybe this one's inappropriate, what I've done here. Be more appropriate would be go right on that lug that I cut. This terminal, ooh, don't short that out, John. Oh my gosh. Shame on me. Oh my gosh. Okay, I better stop for a second because I just stuck my fingers into a live radio. Duh. Yeah, lucky. Wow. Lucky. Oh, yeah, I better just go and think about what I just did. Yeah, moving too fast. Okay, so I've relocated the negative connection. Now that the capacitor, the big capacitor is out of there, there's a little more room to operate. Taking a wire, it's just running right along the chassis, right up to here. That's where it was originally connected. Okay, let's give that a try. See if that makes a difference. Maybe a lesson's going to be learned here. Maybe. Remember, I said I could hear this hum. It didn't quite sound like a. Whoops! Didn't quite sound like a power supply hum. Ooh. Okay. little too close there. Let's put this over here. Switch that right off. Okay, now shame on me for my safety error of the worst type. So, by the way, I'm powering all the stuff in my shop through an isolation transformer. Not this one alone. There's another one behind this. So, getting a shock to ground, like my foot on the concrete basement floor, not going to happen. Shouldn't happen. But, okay, here we go again. Dim lights in. Let's just go back to one. One light. Here we go. Okay, so it's brighter this time because there's only one light. Let's see if I'm any brighter. In some radios, this grounding chassis thing is handled quite differently from one radio to another. In some cases, they use kind of like a star grounding point. There's other ways, probably to try to battle back exactly the hum that I'm battling here. Well, so far sounds like it did originally. Oh, much better. Let's give it the full enchilada here. It's still hummy, isn't it? What have we got? Volume sensitive. It wasn't volume sensitive before. So this might be really immaterial when I turn the volume up this high, because if there was a program there, let's put an antenna on it and see what transpires. Oh, that's terrible the way it sounds. There's another problem going on in it. Oh, that hum is really too strong. Yeah, something's not working. How do you get through it till it is working? That is definitely the question. So this is similar now to how it was.
Put the fingers down.
I'd say it's worse than it was before I went ahead and did what I did. Oh boy, that's really not the objective here. Make things worse. Now, the other capacitor is installed. It's wired the same way the original one was. Let's do a little bit of experimenting here. Let me take this off. Oh, holy smokes. It's not making any sense. No sense. Basically, I have a long wire connected to the radio now. retune the antenna here. Wow, I should quit right now. Things are going downhill rapidly. Where'd the station go? Where'd you go? Way off on the tuning here. That's what it is. Tuning of the antenna. Come on. This antenna's in the wrong angle, probably. Let's put it back down here. Yeah. Tune the radio.
A timeless drink for modern times.
Tune the antenna.
If we win the cash with my Big Mac, I think we'll be buying.
Fine, but if we win the car with my quarter pounder, I get to drive.
Well, what if we win on the fries?
Wow. Sorry about that. What I want to compare here is the signal to noise. See a lot of the noise disappear? Okay, on to the hum. On to this hum problem. I'll take that off. I'm not really commenting on why the noise signal to noise ratio is better, because I'm not sure, but I believe it's because of the low impedance of the loop antenna. I'll make sure this tube isn't laying right on that. It's going to get warm. There. A bit of a gap there. I should get this rubber mat out. So, what's making that sound? What is sensitive? I'm going to take my sensitivity tool here. Just grab this wire. I don't seem to be interested in it. Okay, well, this guy floating around out here now. I'd expect a little bit of change like that to change the hum? I don't think so. Seems to change a little bit with the volume control. The most sensitive wire, I think, would be the wire feeding the volume control. That is this one. We do have this connection for a phono, which I would not recommend anybody to use. Is that part of the picture? Should be before the volume control, so I have it turned down, so I will use my finger. So hum not coming from there. Hum has to come after the volume control. After the volume control. So the volume control side, I guess, is a lower impedance than the tube side. See this one? This green wire is heading up top. Yeah, there could just be a hum level in this. Oh, there's a couple problems here I haven't really considered. One is this tube should be shielded. I don't think this is the kind of hum though that comes from a poorly shielded tube. We can pull this grid cap off and see what we get from that. I should be able to do this with the power on, but good. Cap's loose. Come off. I think what I've just done is I've disconnected the volume control from the grid of the audio preamplifier tube. Okay, power back on. What do we get now? So the sound you hear coming up in the background is my air conditioner coming on. Yeah, air conditioner, middle of October. So, well, still hear it. Let me turn it around here. Doesn't seem to be much different than it was. This might make for a loud sound. Didn't even touch it. So the grid here is basically a wire in space. So the grid is now an antenna, and I'm just bringing up a source close to it. Shows you how sensitive that is, though. So the volume is right down. I think of the end of the amplifier past the volume is wide open, so to speak. It's full blast. So I think that's where the hum is coming from. This wire. What if I change this wire with a shielded wire? I would bring it up to here. Well, can't hurt, can it? Making wire connections onto these caps is a problem. Caps are steel and they don't solder, so they're usually crimped on, so you don't fool around with these too much. I can bring up an alternate wire. I'll be smart. I'll leave the one there. That's there. You can actually come right over here and shield it here. And there's a resistor right there. It's a large resistor. Maybe it's gone open, causing the grid circuit impedance to go up higher than it's supposed to be. It's supposed to be, well, let's measure that resistor. Let's measure the resistor. Typically, my experience is these little resistors that are not doing a heavy duty generally are okay, but generally is not specific to this. You know the old thing about the average people are like this, average people are like that, but there's no average people. So nobody, in fact, is like that. Looks like a mega ohm. Brown, black, green. I think that's the problem. I think that might be the problem. Looks like it's open. Oh, there it goes. 10. Oh, maybe it is 10. Maybe I'm wrong in what I'm saying here. I think, man, brown, black, green. Brown, black, green. My little cheater here for times where my brain stops working. Let's use it. Brown. Black. Green. Well, that's 1 megohm. It's measuring 10. Is it almost exactly 10? Try it again. Pretty curious. It's almost exactly 10 times the size it's supposed to be. Something going wrong here? Maybe there's a little voltage here or something. No, gonna get the same reading. Let's look on the schematic and see what it tells us here. So what we're looking for is the resistor right on the grid of here. 10 megs, 10 megohms. What? Wow. What if I drop this to lower the impedance of the... I'm arguing that the impedance of this wire is so high that it's acting like an antenna. With a 10 megohm resistor here and a brand new capacitor there, that could be the situation, that this wire is just it's just too much of an antenna. If I use a shielded wire, ground one end of the shield, maybe down here, and feed it up there, will that make a difference? I almost never see shielded wires. Well, you know what? I think from time to time they do use shielded wires exactly this way. No, he's changing the resistor. It says 10 megohms there. There's no doubt about it. What's the matter with the way I... Yeah, what's the matter? What's the matter with you, Jim? That's the question. So if that's not a 10, what's a 1 megohm resistor look like, for crying out loud? A 1 megohm resistor. What do you look like? I need some certainty. I need certainty. I need certainty. Let's see if this is certainty. It says 1 megohm. It's a green. What's happening to me? It's 1 megohm with a green. Is that a blue? What's next on the list? Yellow, green, blue. That must be blue. That must be a blue color. That would explain it all. It's a blue. You know, a male. Green, blue color problems. Genetically, something's interesting about our ability to see color. The green and the ability to see green and blue comes from a part of your one of your chromosomes. Let's call it this one here. Maybe you have 23 chromosomes or something like that. I probably got this all wrong. But the color, seeing green and blue, comes from over here. But the ability, or green and red, I guess it is. Green and red. It's not even green and blue. Yeah, enough of that explanation. I'll finish what I was going to say anyway. Two of the colors you see come from this chromosome, and the other color, blue, I'm pretty sure it is, comes from another chromosome, another gene on another chromosome. They're not even together. Suggests that we could originally see green and blue, green and red. Oh my God! Yeah, it's a wonder I don't get more things wrong. Oh, there's more things in here I can get wrong. Shielded wire. Gonna do the shielded wire thing. I'm just babbling now. Okay, next challenge is, can my shielded wire, it's kind of fat, get through the hole here? And that means I'm gonna have to cut the cut the wire that's there, pull it out, see if we get through the hole. Wow. No. Means I have to drill the hole out. I gotta find a smaller, finer piece of wire. Okay, it would be a big hunt to find a smaller piece of wire, so I'm gonna test the one here. Get this off. Pull it out. Ooh, that looks pretty small. Yeah, not gonna go, not gonna go. Decision time. Do I drill that bigger? What are my options? Not many options. I go to drill it, metal shavings. Can I just work it bigger? Can I just work it bigger? Let's say that one more time. Is there any chance of just working it bigger? For a tool here. Here we are. It's a pretty hard steel chassis, so I doubt it very much. What am I poking into? Chopping everything apart up above. No. Did that by any chance make it bigger? Oh, the jackpots we do get into. Oh, this has a little filing thing here. If I worked away at that long enough, it would go. Pretty close. I'm whacking this tube with this tool here. I have another round file. There it is. Let me just grab my round. Wow, it's a bit of an old guy. Lots of leverage. That looks bigger. Presto. Excellent. Okay, let's go with this wire. Now we need to make it the right length. I'm rushing. Rushing is bad. That would be good. Something like that. Okay, and we need to extend the shield to get to this ground terminal. Be generous. Very good. Okay, I'm going to get this wire installed and we will try it out. The clock on the wall says it's lunchtime. Oh boy, I've been here way longer doing this than I expected. Let's get rid of this mat full of wires. Okay, so I've got the connection made down here. Oh boy. A little bit of a frayed situation. Afraid. Okay. Connection up here. What I did was I cut the green wire up here on the grid cap and left a leg out to solder to, because you can't solder to the actual cap. There we are. Okay. This will be the last thing I do today. thing I do to this radio today. Bring it around. Okay, here we go. Let's just think about this for a moment. Off. Good. Good. What's gonna happen now? Jumped out of the pan into the fire. Let's give it a little more voltage. I think it's a little quieter. It's definitely a hum in it still. It's just possible when the signal is being picked up and the ABC voltage appears that the hum is actually going down. That's a tough one to hear. Not that buzzy hum. This is the more the mama. I'm just muttering at this point. That's all that's coming out of me. Just a bunch of mutteration. So now we don't really know for sure that that really had a benefit, putting in the shielded wire. Down, down, down.
Instead of being under the Capacitor, but I think it's great. You know, we all want from players. I think it's fantastic. I'm sure there's fans were just revved up beyond belief seeing that.
Let's try something crazy and plug it right into a regular outlet. Wouldn't that be crazy? That's a crazy idea. Oh, what's all that? What was that?
Just come on. Anything else?
Okay, I'm just getting a little too upset here. Okay, out of here. Into a regular outlet. Is there any equipment connected? Just the antenna, nothing else. I'm okay. It's okay, she's okay. Shouldn't worry too much. It's a transformer-based radio. Yeah, sounds the same.
Get him in practicing with the team before we jump him in.
Well, that's kind of a... Could be coming from tubes. I still have a tube I'm supposed to shield back here. I haven't shielded yet, but that's... Just don't see how that can... I don't see how that can cause this kind of problem. Reason is the volume's down. So it's got to be in the audio side of things. Oh boy, that didn't go so well. My gosh. Oh my gosh. I think it sounds the same as it did originally. Yeah. Okay, well that's it for me today. I'm definitely worn out here. So thanks a lot for watching. I'll ponder this today and see if I can figure out where or what I can do about the hummy sound. Oh boy. See ya.